So here is another question on thermal expansion. It is given that the volume of a metal sphere is it increased by 1% of its original volume when it is heated from a temperature of 320 Kelvin to 522 Kelvin. Calculate the thermal expansion coefficients alpha, beta and gamma for the metal sphere, that is linear surface and volume expansion coefficients. So here the question is based on volume. The information which is given, it is with respect to volume. So let's say the initial volume of the metallic sphere that is equal to V0. Okay, here the increase in volume, okay, the increase in volume is 1/100 of the initial volume V0. Increase in temperature is final minus initial. The final is 522, initial is 320. It increased from 320 to 522, so final is 522 minus 320 Kelvin, that is equal to 202 Kelvin. Okay. So now, as per the volume expansion formula is given, the increase in volume delta V, okay, this is delta V, the increase in volume, it is not delta V0, okay, only delta V, increase in volume. Okay, so here the increase in volume is 1/100 of the initial volume. So here, as per the formula of volume expansion, the increase in volume delta V is equal to the volume expansion coefficient gamma, the original volume V0 and the rise in temperature delta T. So here if we make the substitutions, the increase in volume is 1% of the original volume, that is 1/100 of V0. So it is V0 by 100, which is equal to gamma, which is the volume expansion coefficient which we want to calculate, the original volume V0 and delta T, which is equal to 202. So here V0 gets cancelled on both sides. That implies the volume expansion coefficient gamma is equal to 1/100 into 202. So it is coming around 4 points. So if we round it off, so it is 5 into 10 to the power minus 5 per degree Celsius. So we have calculated the volume expansion coefficient gamma. So now we'll use the interrelationship between the thermal expansion coefficients, that relationship. So here we have calculated gamma, which is equal to 5 into 10 to the power minus 5. Now the relationship is, which we have already studied, it is alpha is equal to beta by 2, which is equal to gamma by 3, this relationship. That implies alpha is equal to gamma by 3. The linear expansion coefficient is equal to 1/3 into the volume expansion coefficient, which is equal to 5 into 10 to the power minus 5 by 3. Okay, so it is coming around 1.67 into 10 to the power minus 5 degrees Celsius. that is the linear expansion coefficient alpha, and then beta is equal to 2 alpha. So that implies beta is equal to 2 into 1.600 to the power minus 5, that will be equal to 3.34 into 10 to the power minus 5 degree Celsius. Okay, so we have calculated first the volume expansion coefficient gamma, and then using the relationship between the thermal expansion coefficients alpha, beta and gamma, we calculated alpha first, the linear expansion coefficient, and then the surface expansion coefficient. Okay, so this is the thing. Alpha is equal to 1.67 into 10 to the power minus 5 per degree Celsius, beta is 3.34 into 10 to the power minus 5 per degree Celsius, and gamma is equal to 5 into 10 to the power minus 5 per degree Celsius. Rounding it off, of course. It's coming around 4.97, so we rounded it off. Okay, so this is the thing. So here is another question. It is given that two rods, one of aluminium and the other made of steel, having initial lengths of L1 and L2, are connected together to form a single rod of length L1 plus L2. If the length of each rod increases by the same amount when their temperatures are raised by T degree Celsius, then find the ratio of L1 by L1 plus L2. And here the information is given, extra information, that the linear expansion coefficients are alpha subscript A for aluminium and alpha subscript S for steel. So we have to find the ratio of the length of aluminium rod to the total length of the combined rod in terms of the expansion coefficients, and let's see whatever other parameter comes into the equation. Okay, so here the basic concept of thermal expansion will come into play, where rise in temperature delta L because of temperature increase is equal to the linear expansion coefficient, the initial length, okay, whatever the initial length is, and then rise in temperature. This is the basic thing. Here, according to the question, we have two rods. One is of aluminium having initial length of L1, and another one is of steel having initial length L2. Both are joined together to form a single rod. So according to the question, when temperature is increased by T degree Celsius, the increase in length in both aluminium and steel, they are the same. So according to this expression, delta L1 is the initial length Li, rise in temperature T, and the linear expansion coefficient for aluminium alpha A, this much, and the increase in length in steel delta L2 is equal to the initial length of steel, which is L2, rise in temperature T, and the linear expansion coefficient alpha S. Then we have this delta L1 is equal to delta L2. That implies alpha A L1 T is equal to alpha S L2 T. T gets cancelled, so that implies alpha A L1 is equal to alpha S L2. That implies L2 by L1 is equal to alpha A by alpha S. Okay, alpha A by alpha S. L2 by L1 plus 1 is equal to alpha A by alpha S plus 1. That implies L2 plus L1 by L1 is equal to alpha A plus alpha S by alpha S. Now we are asked to find L1 by L1 plus L2. So simply taking the reciprocal, that implies L1 by L1 plus L2 is equal to alpha S by alpha A plus alpha S. This is the answer. Okay, this. Okay, L1 by L1 plus L2 is equal to alpha S by alpha A plus alpha S, where alpha is the linear expansion coefficient for steel, alpha A is the linear expansion coefficient for aluminum. Okay, so this is the